So in this video, what we want to look at is a more generalized form of types of integral that we're going to be dealing with. So in these, we're looking at the integral of 1 over the square root of a squared take away x squared, and the integral of 1 over a squared plus x squared. Okay, so the idea is that can we use our knowledge that we've built up so far in order to integrate these? Now, this is looking like it is of the form of our first example here. So in the previous video, well, in the previous videos, we looked at integrating this when a was 1. And we used the substitution x equals sine of u. Now, the way that this worked out was that we wanted to get to an identity that involved sine. Okay, so we got to 1 take away sine squared, which was cosine squared, which we could square root. So that's the same process that we want to go down. Okay, it's the same things that we want to do. So how am I going to make sure that I'm going to get an identity that I can work with? So if instead we had x equals a times sine of u, then I know that I'm going to be squaring that and getting a squared sine squared. The a squared I can factor out, leaving me with 1 minus sine squared, which is cosine squared, which I can square root. So this substitution will allow all of that process to work behind the scenes. Okay, so let's see it work. So dx by du would be a cosine u. So dx is a cosine u du. So we would have the integral of 1 over the square root of a squared take away a squared sine squared u. And the dx is replaced with a cosine u du. Now you might think this is looking quite complicated, but what we can do is we can factor the a squared out of the denominator. So in the numerator we've got a cosine u. In the denominator, if I factor out the a squared, then I've got the square root of a squared 1 minus sine squared u du. Now here we can have the a cosine u over, now we've got the square root of the a squared, which is a, and we've got the square root of 1 minus sine squared, which is the square root of cosine squared, which is cosine u. And so both numerator and denominator cancel down to 1. So this is equal to u plus c. And if x is equal to a sine of u, then u must be equal to, now divide both sides by a first, and you get 1 over a times x. And so this is equal to arc sine of x over a plus c. So I now know that this integrates to this. Okay? So you might be thinking, oh, well, now I might be able to have a guess at what the answer to this is going to be. Okay? So in the same way, in the previous video, we had x is equal to tan of u. So to keep that identity working, I must have a tan of u. So dx by du is a sec squared u. So dx is equal to a sec squared u du. So we have the integral of 1 over a squared plus x squared, which is a squared tan squared u, times by dx, which is a sec squared u du. So in the numerator, we've got a sec squared u over a squared plus a squared tan squared u. So I'm going to factor the a squared out. I have 1 plus tan squared u du. So we've got a sec squared u in the numerator over a squared sec squared u in the denominator, because 1 plus tan squared is sec squared. So this is equal to the integral, the sec squareds cancel, we have a over a squared, which is 1 over a du, which integrates to 1 over a u plus c. And of course, if x is equal to a tan of u, then divide both sides by a, we get x over a equals tan of u. So u must be arctan of x over a. So 1 over a arctan of x over a plus your constant c. So it may well be the case that when you had your guess at the halfway mark as to what this one would be equal to, you might have thought it was going to be arctan of x over a plus c. It's not quite. You've got this extra 1 over a out the front. Okay? And so that is how we can show that we've got these standard form integrals that we now know how they integrate, and we now want to be able to use that to look at other examples in this form, okay? But in a lot of cases, we need to get it into this form in order to integrate them.